Hey, my name is Dennis Niklas. I am heading up the IoT business for Deutsche Telekom, and it's a pleasure to welcome you to the final demo day of the Accuracy Unlocked program. It had been a great pleasure in the last month to work with those startups, and we are, as Deutsche Telekom and Swift Navigations, we are very proud of the results we see today.
Hi, my name is Timothy Harris, founder and CEO of Swift Navigation. We were founded on a mission of enabling the next generation of vehicles to navigate the world safely and autonomously. Better accuracy means safer and more effective navigation for all sorts of vehicles. Standard positioning from satellite navigation, that little blue dot in your phone's map system, is accurate from 3 to 5 meters, which is not suitable for autonomous systems. Our work integrates bringing precision to 5 centimeters of accuracy for Swift's many customers and Deutsche Telekom's many customers in the automotive and other autonomy spaces. With this reliable, high-precision positioning available across Europe, Swift and Deutsche Telekom enable companies across a myriad of industries to automate their vehicles and improve navigation efficiency, which reduces costs and improves operational efficiencies. An example of how various industries are integrating precise positioning into their applications is demonstrated by the Accuracy Unlocked program. We look forward to seeing the developments brought to life, and through our continued innovation with Deutsche Telekom and expanding our service and improving positioning across all of Europe, we were building together an autonomous future.
My biggest thank you to the Accuracy Unlocked program team. The mentors supported the startup with technical expertise on the one hand and with business knowledge on the other hand to make the progress even better. We are very proud to welcome now our 12 finalists coming from 7 countries, working in 6 different verticals, showing us the great capabilities of precise positioning. Now let's see what the finalists prepared for us today.
Accuracy Unlocked. 470 startups scouted, 48 longlisted, 12 selected from 7 countries in 6 areas of innovation. Precise Positioning is a cloud-based GNSS correction service that makes satellite navigation more accurate and reliable. New possibilities require new solutions. That's why in Hubram, DT's Tech Incubator, we started, together with our partner Swift Navigation, the Accuracy Unlocked Acceleration Program. We invited startups and small companies to develop use cases that adopt, integrate, and optimize precise GNSS positioning technology to create value and innovation for their customers. We believe that there are unlimited possibilities for this technology to shape and scale new use cases that will improve all of our lives for a better future.
Hello and welcome everyone to the final demo day of the Accuracy Unlocked Precise Positioning program. We are really glad to have each and every one of you here. Before we start, I just want to give you a short throwback of what has happened the last month. The program has started end of April. We started with our 12 startups. They've all received the hardware and the software to bring their product to the next level with precise positioning. Over the past months, they had lots of help from our mentors. Thank you so much to each and everyone who has supported them throughout the program. Before we start today, I just want to introduce you to the jury and welcome to jury Angsa Marie, IoT and Smart Business Development and Partnering Manager at Deutsche Telekom, Babak Aganji Talesh, Technical Product Manager at Deutsche Telekom, Daniel Optendreng, Senior Director Business Development and Partnerships at Swift Navigation, David Schröder, Senior Expert at Group Partnering and Devices for Deutsche Telekom, Dennis Nichols, CEO of Deutsche Telekom IoT, Fergus Noble, co-founder and CTO of Swift Navigation, Jerzy Krysiak, Head of Hubram Krakow, and Christoph Moore, Manager Innovation, Portfolio and Strategic Partnerships at Deutsche Telekom. Dear jury, thank you so much for being here today, for taking the time, and let's welcome our first startup here, AI.Land, based in Germany, working in robotics and agriculture.
Today's farmers face uprising challenges in a global market. The shortage of skilled farm workers, the prohibition of chemicals and electrification of agricultural machinery present future challenges. Thus, EtherRob aims to decrease monotonous and physical demanding fieldwork by automation and integrated digitization.
Localization is essential for a mobile robot. The robot needs a global but as well as local pose. The global pose of a field robot can be easily determined via GNSS.
A global GNSS-based localization strategy can be improved by adding local features, such as odometry and IMU data or plant pattern recognition. Most of today's field applications can be realized using a reactive path follower and a robust multi-data localization strategy. The omnidirectional kinematic of the EtherRob simplifies the path following process. It decreases turning areas and allows quick drive mode changes. In the future scope, autonomous path planning will become a bigger part in agricultural robotics. Intelligent field robots will increase uptimes by actively avoiding collisions via bypassing. The autonomous approach to service points enables automatic tool change or refilling of working supplies.
EtherRob is designed in a modular way to satisfy research demands as well as intense field trials with local farmers. Like many other mobile systems, it consists of a battery to buffer power combined with a range extender. The other side hosts a control cabinet, communication systems and some sensors. To combine different production processes, like for example fertilizing and weed control, EtherRob features 2 tool slots in this configuration.
One challenging and interesting application is a selective weeding system. Here, a high voltage electrical shock is applied to the weed in order to destroy the biological tissue.
The advantage of a selective weeding approach without chemicals is quite obvious. The discussion of a glyphosate-free cultivation of crop plants in Germany motivated us to develop the following system based on machine learning algorithms combined with standard image processing techniques to identify and localize cultivated plants.
Methods based on deep learning have proven to be robust and precise in classification and segmentation of crop and weed plants. One major factor closely related to the model performance is the quality and quantity of the training dataset. Traditionally, the generation of a dataset for object detection is time-consuming and costly.
Therefore, we enlarged our dataset with photorealistic synthetic subsegments. We make use of highly detailed 3D models of crop and weed plants. By mutating the properties of these 3D models, we can generate a diverse and large dataset for all plant models.
This approach enables ETAS, our field robot software, to adapt to different domains like day and night, rain and sun.
AI.Land, thank you so much for your great presentation. We want to start our first Q&A of the day, so you've got 10 minutes. So I want to give the word to the jury now. Feel free to start asking your questions.
This is Babak. Can you just explain a little bit more how you work GNSS positioning into that solution exactly? There was a lot of optical recognition, but I believe GNSS positioning is also a very important part of that solution.
Yes, that was the main work with the Swift team and Telecom. So for us, it's very important to have a security-safe geofence around the fields so that our system can operate safely in the workspace of the farmer and is not entering like road traffic and stuff like that. So the GPS is mainly important for us to keep the geofence, but then also use it for an open field navigation. So we have 2 states of navigation. We are in the row where we can follow the plant patterns, or we are on the open field, so at the end of the rows where we have to enter a row from 1 to 1000. To find this individual row, it's very good to have a secure and accurate GPS signal.
The market you're aiming at, is it just Germany or Europe?
Yes, we are mainly aiming for Germany because here we have the highest standards in biological vegetable production. For us, the other areas in Europe are also very important. Netherlands is of course close by. French is very important for the wine market. But we see still that in Italy and Spain, for example, that the labor is very, very cheap, especially to the refugee situation that we have right now. Anyways, it has to change in the future, so Europe is all over in the market for field robots in the next 20 years.
We want to move on directly to the next startup and welcome Angsa Robotics. We're really happy to have them here as well today. They're also coming from Germany. Their field of expertise is in robotics and outdoor cleaning. So what exactly that means, you will see in a second when we show you the video.
Hi, I'm Lucas and I'm one of the co-founders of Angsa Robotics. We are a small startup from Munich and we developed the world's first autonomous trash picking robot. On this image you can see a completely trashed marketplace, but luckily the sweeping machines do a great job here. The place will be clean in a couple of hours. On other surfaces like grass or gravel, this does not really make sense. These machines destroy the ground and they leave behind the small trash. Small trash, but large impact. One cigarette can pollute up to 40 liters of water. We believe that the whole removal of trash on these surfaces can be solved automatically. And our solution for this is the trash picking robot. It consists of 3 core technologies: the live trash detection powered with an AI, the targeted removal for the objects, and the autonomous navigation using precise positioning together with other local sensors. Precise positioning is relevant to us in 3 different domains. Firstly, we increase the usability and safety of the robot with these positioning techniques. The user can give the robot an area which it is allowed to operate in, the geo boundaries, and the robot will not move outside. So it should not move on unwanted areas like pathways or even dangerous areas like water. Additionally, it increases the performance to up to 240% compared to standard GNSS. This is because the more accurate we can localize ourselves, the better we can drive our lanes, and then the faster we will be. Finally, we use the precise positioning for our data analysis to identify trash hotspots. But enough on the why, let's talk about the how. On this image you can see the PGM EVK mounted onto our robot Clive. And here we have actual real data from the Luitpold Park in Munich. You can see that the lanes the robot is driving are super straight. And here we are driving just at the edge of the grass, exactly where the robot should drive. Even under the trees, we do have a good signal. So, to sum it up, we cannot emphasize enough how important precise positioning already is and also will be to make our product viable for the market. We are very happy to have gone through this collaboration with Swift and Telecom. Thank you very much.
Hi, Lukas. I would like to ask about the public spaces you aim to clean up. What are these apart from the parks?
So, as you say, mainly we target the parks. That these are the public areas, and then we have the two other segments. These are the festivals and private companies like open swimming pools. These are our core customers. I guess that was the question.
Sure. So a follow-up, do you need a special permission to operate in the park, or the robot is so small that it can't harm anyone and no permission is needed, for example, in Germany?
We are still in a prototype stage, so we do not have a certification yet. And what we will need will be a CE certification once we enter the market. But the robot does not have the same restrictions as, for example, a car would have due to its size and its weight.
How much trash can it pick up, Lucas? So, because I've seen some festival sites and they're a pretty bad mess afterwards. So, how often do you have to re-empty it or something like that?
So we have a trash can which currently has a volume of 30 liters. That might sound not so much, but given that the robot is specialized in a small trash objects, like for example cigarettes, bottle caps, we calculated between 10,000 bottle caps, 20,000 cigarettes, so that is a lot. And of course, it won't operate completely autonomously, but will be emptied by humans.
Yeah, this is Barbara. Just a quick question. So you use precise positioning for the geofencing, I learned, but is it also relevant for the navigation algorithm?
Yeah. So that was actually the second part of the three different areas which I presented. We need to, if we don't use the global localization, we do have a drift with our local localization. So that's where we use it for the navigation. And as that there was the part for the 240% increase in performance, because we can make the lanes more precise, and we don't have to drive over the second area at the same time.
And we want to move on directly to our next startup, which is auvetech. auvetech is based in Estonia, and they have operated, or they are operating, in the automotive vertical, and they're working on a self-driving transportation. So we're really curious to see what they have.
Hi, welcome to Estonia, Tallinn. My name is Jorma, I'm from auvetech, and auvetech is an Estonian company building the world's most flexible last-mile transportation system without shuttles.
Precise positioning is the key to a safe and efficient navigation. At the moment, the shuttles use LiDARs for understanding their surroundings. However, if something happens to them, we would need a redundant source of localization. For that, we used RTK. During this project, we installed the device into our vehicle. We've tested it in our operational areas and the testing grounds, and we have proved that the system works.
The device has been installed on our shuttle, and at the moment we're using RTK only for localization. We're not using any LiDARs, and as you can see, it's safe and efficient. Both of the GPS maps show that in some places of the route, the two sources of position do not match exactly yet. These are the areas that will require further investigation and development to push this solution into our production. We believe that this is just due to the time constraint of the project, and this could be sorted within 1 to 2 months of development, and the system could be made perfect. Future-ready transportation, precisely.
That was auvetech from Estonia. Thanks for your presentation. You already know it's now time to move on to the Q&A. So, dear jury, please feel free to ask for questions now.
Yeah, so I'll start. Thanks again, Jorma and Asif, for testing all of this and even sitting in the car. Where do you actually, do you just see precise positioning as a redundant system, or is it something that you will run in parallel to the LiDARs?
Yeah, it's something that we can parallel to the LiDARs as well, because making a LiDARs map takes a lot more time, and if we would need a very fast way to set up the map, then RTK would be a fantastic way to use that. And it is something that needs a bit further development, but I think it has very, very bright future for our tech.
Thank you.
Is there also a cost issue as well? LiDAR against it, or?
Yeah, it's like tenfold at least, because LiDARs are very, very expensive compared to GNSS.
Okay.
So when can we have a ride?
Come to Estonia and be my guest. But we actually operate in loads of countries in Europe as well, and in September hopefully we'll be in Netherlands, for instance. So check out our pages and see where we operate, and if you're nearby, then absolutely come and have a drive with our vehicle.
So you're already live operating in public areas, right?
Yeah, and legal as well. Like in Estonia, as you can see, we have all the registration and everything on it, so it's something that really works already.
Can you talk about the business model? Are you operating the vehicles directly, or are you selling the vehicles to campuses and other?
Yeah, at the moment we're operating the vehicles directly, and yeah, like you said, the main operational areas would be or are campuses and city centers and small areas where cars aren't feasible.
Then let's move on to the next startup already, which is Capra Robotics. They're based in Denmark, and they are actually working on outdoor mobile robotics. And one of their work robotics are doing is removing or cleaning the cigarette butts. So we're really curious to see their video, and Niels is here with us as well. So hi Niels, welcome. And with that, let's kick off the video.
Hello, my name is Niels Jakobsen, and I'm the CEO of Capra Robotics. Capra Robotics develops and produces mobile robots for outdoor usage. We started in 2019, and our next month, that's September 2021, putting our first product on the market. We are currently 17 full-time employees, a lot of students who help us in the development. In this project, we are considering a big problem of cigarette butts. They are the most frequently tossed items in the world. They are highly toxic for the water and are also classified as plastic and in any way considered harmful for the environment. In Denmark alone, more than 6 billion cigarettes are smoked annually, and estimated 7 million cigarettes are thrown in the cities daily. This consists in the world to more than 4.5 trillion cigarette butts that are thrown away. And in Aarhus alone, it costs 3 crowns to pick up each cigarette, so that has a high motivation of finding a better automatic solution for this. And here we come up with a concept here of Body, a robot that automatically can help with this problem. It consists of an AI system to identify the cigarette butts, a suction unit to remove the identified cigarette, and a mobile platform, in this the Capra, who will provide the mobility for the system, and a precise positioning unit who will help us identify where we move around the city. And here you can see the concept in real. The precise position is needed in our case, as we have to drive where the butts are thrown, and in this case it's on the sideway. And this requires for us to move within centimeters of accuracy. In this project we used a PGM evaluation kit that is placed in the center of the robot, as you can see on the picture on the right. The PGM system then sends the DNS position signal to our control system, that is a ROS-based system that's in the center of the robot. In the first case, you can see here some of the pavement drives we made to test the system working. I have to say this is still done manually, as we are waiting for permission from the Danish Traffic Act in order to do this automatically. Today we are only allowed to do that within confined areas. The solution you can see here operating in real life, where the robot moves around, identify the cigarette and suck them up. The camera on the left lower, you can see the view from the robot part, and here you can see the AI system identify the different bots in order to move them. That's all. Thank you for listening.
I have the first question. Dennis is speaking. Hi, Niels. Thank you for your video and your solution, which supports our sustainability targets, obviously. One question, how many butts you can collect per hour with this technology? Yeah, because it seems to be a really one-by-one collecting method. Yeah, what do you expect from your solution?
I think we expect to about 2 or 3 seconds for each cigarette. So you're correct, because the cigarettes are also not always confined to just one area. They are spread around, so we need to go and identify them first. I think that we planned in municipality in Aarhus to have about 100 robots, and they would about cover most of our needs for that purpose.
Okay, thank you.
I've got a question. So why did you choose to focus on one type of litter, which is a cigarette butt? Will not that be a little bit more efficient if you pick up other little on the way? Or the system is super designed to pick one and efficient in that, and then you need more robots to pick the other kinds of litter?
I think it's a general system, so the bot is just the first example. So we're actually working in other programs with weeds and also to take chewing gums. So you're correct there. It's a general platform, it's a general solution. I think we address the bot problems first because it's actually it's a huge problem, and if we can solve that, we can really make a change for the environment.
Cool, thank you.
Hi, Alex. Can you talk a little bit more about how you use the precise positioning and why it was important to your application?
I said that we have to operate on the sidewalk there. So we have to operate along the street. So we have to be very sure also that we are not driving out on the street. I think within this project here, we just need a few centimeters of accuracy because the navigation system will also have to look where the cigarettes are and then move a little bit on the side to do that. But basically it's to give us the precision we need to be on the sidewalk and not the road.
And with that, I want to move on directly to our next startup, which is Kingdom Technologies, based in the UK. They are working in agriculture and they have developed robotic mowers. So they will be with us in a second, and we are super, super curious to see what they can show us, what they've prepared, how they use precise positioning.
Hello, my name is Johan and I am the CEO of Kingdom Technologies.
And I'm Matthew Shields, I'm the CTO.
Robotic lawnmowers have been around for a while, but they still possess a number of shortcomings. Firstly, they move around in a random path and therefore cannot cover large areas. They also require the boundary cable installation, which also limits the working area, and the boundary cable often has to be reinstalled. They also use reactive safety measures, which does not provide the highest level of safety. Our robot has solved those shortcomings. First of all, our robot moves around in a human-like pattern and therefore can cover roughly 10 times larger area than traditional lawnmowers. We've also developed a web platform that enables it to define the working areas and times and therefore does not require the boundary cable installation. We are using onboard sensors in order to ensure the highest level of safety.
For the Skylark and PGM evaluation, we did a hardware setup comparing the PGM and a standard GNSS receiver operating with a standard positioning solution, GNSS. All of this hardware that's shown on the slide was mounted inside one of our robot shells. The first test we want to do was a path following and path planning test. So what we have here is an area of grass where we know the ground truth for the cutting lanes on it. We decided to use 3 sets of 3 40-meter lanes, each at 1 meter apart for the test. We manually controlled the robot rather than having it control itself, and cycled the cutting motors during the test as a source of electromagnetic interference to try and interfere with the GNSS. The results, a typical set of the results are shown here. The bias of the GNSS was greater than 0.5 meter in some places, whereas compared to the precise positioning solution, it was less than 5 centimeters, which is really good for us. And this is very important, as ensuring that we get full coverage of an area when we've got a planned path is critical for our customers. The other test we wanted to do was docking. We used a surveyed charging station location that we have in difficult GNSS conditions, so with a tree and some buildings around it. We placed the robot in front of the charging station and logged data over 1 hour to see what the deviation in this position was. You can see the spread of results here. Standard deviation for the GNSS was around 90 centimeters, whereas for Skylark it was around 12 centimeters. This is critical for us, as the handoff between the positioning that we use for path planning and what the positioning that we use for docking, which is a relative method, and that last position and orientation is critical. And if we can't dock, we can't charge. In summary, Skylark Precise Positioning provided markedly better results when compared with standard positioning solution from GNSS. Skylark Precise Positioning solution can be utilized to solve many robotics problems, 2 of which we showcased here, and Skylark Precise Positioning provides a flexible solution for devices which are deployed across large operational areas.
Thanks so much, Kingdom Technologies, for your great presentation. As usual, we want to move on to the Q&A now. So jury, please feel free to start asking your questions now.
Yeah, this is Barbara. Maybe I missed that part. Did you also use odometry in your solution, or was it just motion sensing and GNSS?
So it was just the GNSS for the test that we did here, but we do what we have implemented for control at the moment does use a mixture of inertial sensors, IMU, and GNSS and odometry. So we were just sort of validating the GNSS side of things for this particular test with the time we had.
So I would assume that the accuracy could even be further improved by adding the sensors, as you mentioned, IMU and odometry, and filtering out the results.
Yeah, and also the robustness to things like GNSS dropout and things like that. So.
And if I may, just another one. So the position of the charging station, I mean, that was like close to a shed, directed to a wall, sort of shielded. Is that representative? I would assume a lot of people just put it next to a wall, which is sort of the most challenging environment.
Purposefully the most difficult one that we have here. So that's set up at our office, and it's purposefully meant to be more of a challenge than what we'd see in the field generally for that reason, right? So if we can perform here, then we can perform elsewhere. So.
Yeah, sounds reasonable.
One additional question from my side, Dennis is speaking. You are obviously operating in a very price-sensitive area, right? What do you expect? What will be the uplift for such a device compared to robots which are already in the market? And do you think the benefits of that technology could convince customers to pay that uplift?
I think the main difference compared to the traditional robotic lawnmowers is that they can do they can cover much smaller areas. So the traditional robotic lawnmowers can do up to 5,000 square meters, whereas our solution can cover 10 to 15 times larger areas due to this navigation. And therefore also we're not that focused on the homeowners actually, but we're mostly kind of focused on the commercial customers that where the current traditional robots are not really a viable solution, because you would just need to have a very big fleet of those.
Perfect, thank you.
Let's move on to our next startup, which is Not. Not is based in France, and they are working on shared mobility. So they have a really special system developed. So not as we all know it, shared scooters only, but with a docking station. So we can see them already. If you want to share your video as well. And we are happy to look at the 3-minute video pitch in a second.
Hi everyone, my name is Paulina and I'm the co-founder of Not, and I will tell you how the precise positioning can change the life for our company. To be honest, in the beginning the tech team was not very hot and they're like, oh, no more job. But yeah, we tried it and it's actually very cool, you'll see it. So a few words about Not. We are the company located in France and we provide fixed infrastructure to charge and lock scooters and bikes. This is our main tech. So why we do it is because we think docking station can bring order on city streets. They reduce the vandalism impact, they control the energy supply and reduces operational costs to make scooter sharing profitable. But actually we also make the virtual parkings as well, because sometimes it's just not possible to set up the station, you cannot provide the grid connection, and well, you need to mix all this BOS technology to make the network actually workable. So for us, precise positioning can have a huge impact on 2 points. First of all, on parking, of course, because we can create the virtual parking and actually keep scooters inside the box And this is our philosophy, because we don't want to have a scooter mess in the street, and then also work on the security for the users to keep them out of the sidewalks and limit the speed in pedestrian areas. So for the setup, you need one developer, one scooter, and one Swift PGM case. So Robin will be there afterwards to answer all technical questions. The 9-board IoT is located right on the stem, and then we also add the Swift PGM to compare them both at the same time. And well, let's go for the road. And very first outcome of the map, you can see it over there. The GPS of the scooter is white. The Swift GPS is yellow, so you can clearly see the difference. And if we look closer on how we can solve the problem and going directly on the parking side, so you can see here that actually the scooter GPS was completely out of everything, while the Swift could provide us the fixed positioning for the scooter. So the second problem is safety for the users. Again, the scooter GPS was flying over the roofs, and while Swift kept exact tracking on the road, we can actually observe when the user is changing the side of the road. It gives us a great outcome, and we can hope to track the user when they go on a sidewalk. So what we can exactly do with that? Of course, stop the mess and provide both fixed and precise virtual infrastructure, and keeping the scooter inside where they have to be when they parked, and also provide work on the safety with less accidents, sending notification on the scooter screen where the user is on a sidewalk, and then automatically limit the speed at the entrance of the high dense areas. So that will be definitely scooter sharing 2.0 with fixed and virtual infrastructure, precise positioning. Thank you very much.
Let me go first. Paulina, good to see you again. I think we first met about 3 years ago, and that. So good to hear you're well and that. Where I live in Cologne, they had a new regulation this week about no zones for scooters by the river, on bridges, etc., etc. I'm assuming this can only be realized with GNSS. Is that correct? You need this technology to actually be able to operate no zones. In other words, keep the scooter outside the box instead of inside it.
Absolutely. Well, we already do some IoT positioning, and when scooter, for example, in our network in Strasbourg, some users cross the river to go to Germany. That's not allowed, going from France to Germany. So we already try to influence this, but only way we can do it, we can limit the speed when the scooter enters the no zone, but we cannot do it precisely. So we actually have some mess up with that, and that will be very helpful for sure. And I'm happy to see I've just been in Vienna yesterday. It's a lot of good memories.
Cool. Thanks.
All right. Any other?
Another question, like what other use cases you might see in the future that precise positioning could enable for you? Is there anything else besides the operational topics?
Well, the operational, we just talked mostly about the scooter for users when they park them and when they use them. So how to limit the speed, how to limit the parking, but we can actually work also with the maintenance issues, because sometimes if the scooter was stolen and it would get in somewhere they hide it inside the yard or something like that, we cannot just tell, okay, this yard or this yard. So it can also help us finding the scooter. And we also work a lot with bikes and with other vehicles, so it will be helpful as well. But maybe if you see some other usage, that would be cool if you have some ideas.
And we want to move on to Level 5 Supplies, which is the next startup we are going to see now. They are based in the UK as well and working in robotics, specifically in delivery robots. So they are working on robots that can navigate through the pavements, and we're really, really curious to see their pitch.
Hi, this is Alex from Level 5 Supplies, and this is our take on Accuracy Unlocked. Level 5 Supplies was founded in 2018. We're a UK-based supplier of autonomy equipment. In 2021, we added an engineering team focused on bespoke solutions and integration, as well as new IP creation. As part of that team, I'm joined on my right by Andrew Merrin, robotics engineer, who is leading this project. and we're working on a delivery robot capable of navigating UK pavements autonomously. Navigating pavement. What's the problem? Why is it so hard?
So there are a number of problems with navigating pavements. The first of which is mapping. There are not any good sources of mapping data of UK pavements. The second is planning. You then need to be able to plan the route using pavements, including dropped curbs and other obstacles on the pavements. The third is localization. You need a very high level of accuracy to be able to position your robot and prevent it from falling off curbs. As you can see on this diagram, the level of accuracy we need is down in the tens of centimeters or less. With 1 meter accuracy, we can't tell where we are on the pavement and we can't make accurate planning decisions.
In addition to the SwiftNav evaluation unit, we also used a Jackal delivery robot platform, which has an x86 motherboard running ROS, our own Wi-Fi infrastructure, all controlled from a desktop, and of course a coffee machine.
Putting it all together, you can see the complete package is integrated and mobile, so we are ready to do our testing. We designed a number of experiments to test the accuracy of the robot following GPS waypoints. This included taking known GPS coordinates and mapping a route between them. We then took the robot outside, allowed it to drive between the points, and then we moved on to measure the difference between our known points and the readings of the GPS. As you can see on this slide, we are quite impressed with the results, and we have the accuracy we need, we believe, to navigate the pavements.
The alternative to using GNSS and RTK is GPS with LiDAR or other sensors. These use more power and cost more. The key benefits of GNSS with RTK is the sensor payload can be a lot simpler, lighter, use less power, and as a result is more scalable, can get to market faster, and has better return on investment. The main challenges on the project were integration, the mobile robot platform we actually worked with, and of course the mechanical design and manufacture. We also had some issues outside our control, such as Urban Canyon, the British weather, COVID, and our own IT infrastructure. Next step for us on this project is more time experimenting with the RTK, completing the ROS integration, and do more work with waypoint following, in addition to migrating to our own robotic platform. In short, it's a great platform. We'd like to work a lot more with it.
That was a great presentation, Level 5. Thanks so much. We want to move on to the Q&A now. Jury, it's your time.
You mentioned your own robotics platform. So the platform you used in the test was a third-party platform, right? So can you tell us a little bit more about your own platform?
Our own platform is still quite in development. So at the moment, we're mainly just specifying components and working out the performance requirements necessary for that. And we're still specifying exactly the tasks that it'll have to complete before we can finalize it. So at the moment, we're just on a third-party platform.
And you manage a price difference between employing LiDAR and employing GNSS. Just out of curiosity, so what's the overall price bracket for such a robot, so we can understand? So is 3,000 euros as 5%, or is that 10% or 50% increase?
It would be significant. Again, we're still trying to weigh everything up, and it will depend on the fleet size as well. But it could be quite a significant saving. If you were to save £4,000 or £5,000 on a LiDAR sensor.
Thank you.
I believe there's a couple of companies active in the area of last mile supply. Do you believe that precise positioning from DT and Swift can give you a considerable advantage to the other ones?
I think so. If we can generate better map data, which I think we have a plan to generate our own maps, and then we can have precise positioning within them. I think we can do things in a more simple and scalable way. So yeah, I think so.
Final comment. I can't believe the British weather affected your tests. How did that affect it?
I didn't have time to get the photo in, but at one point I had to make a makeshift shower cap for the robot to get it out in the rain to do some testing. Yeah, okay. We had a few rainy and windy days. Yeah.
And we want to move on to our next startup, which is PANTOhealth. PANTOhealth are based in Germany, and they are working in the vertical of rail, and they have developed a maintenance solution for that.
In railway industry, infrastructure are regularly being inspected by special measurement trains to discover issues and prevent big damages. This method is very expensive and efficient. To save time and money, PANTOhealth offers a predictive maintenance solution that suggests best time and type of maintenance operations. This solution includes 1. A live monitoring system mounted in regular trains that collects large amounts of data from trains and infrastructure. 2. Trains' digital twins based on a mathematical model of train and infrastructure that simulates running train over infrastructure. 3. Artificial intelligence engine that discovers patterns of the problems. In order to understand and predict the behavior of the infrastructure, history and characteristics of each point of the infrastructure has to be stored. The precise geolocation data of these points are identifier of them. So low precision location data leads to inaccurate data collection and faulty predictions of defects. Our customers worked.
At Infravel, we need high accuracy positioning from the problems on our infrastructure so that we can give an exact position to our maintenance crews to intervene on our network. Otherwise, we are just guessing in the wild on a certain section on our track where the problem is, but with high accuracy positioning, we can really pinpoint to the exact location where the problem is, and that really helps us improve our maintenance.
Precise positioning is the vital part of PANTOhealth's solution. Thanks to Swift and Deutsche Telekom, PANTOhealth is able to record locations reliably with an accuracy of 10 centimeters. In the test case, the Swift evaluation module has been installed alongside PANTOhealth's solution to compare quality and accuracy of legacy positioning with Swift precise positioning. The result unsurprisingly proves that without precise positioning, live monitoring and predictive maintenance of interaction between railway and infrastructure will not be possible.
I've got a question about the failures you discovered. So what kind of failures are these? Because if I think about the traction or the network, and if there is a problem, like it really is like a meter lower than the average, then you don't need to be as precise compared to standard GPS, or it's not visible by bare eye, and it can only be detected via your system. Then it makes sense, obviously, to be much more precise. So what do you detect?
Actually, there are more than just like that. Probably some screws are loose, and there are like sometimes like some parts are stretched that they are like not visibly. You cannot even see those problems. And I mean, without giving like exact location, they cannot use the test material to even find out if there's a problem. So like probably Fazal can mention some more of those problems in the catenary.
Yeah, exactly. For example, when one dropper is loose, you cannot even see it. And our sensitive sensors, look like our accelerometers or arc detectors, can find the problem in the catenary. And for sure, we need the location to tag this problem or pinpoint the problem.
And how often does it occurs to have such problems? Is it like super rare occasion, or it's really a big problem for the railway?
It's really common for our case in Infravel. I can say right after installing our device, they asked us to find a deep problem which is damaging several pantographs per day. I can say 1 week after our installation.
Great.
Can you talk a little bit more about the data you showed in the final part of the presentation? Was that just a representation, or was that the real data from the test?
Actually, it's a real data, and this is not from Infrabel. This is from another company that we tested the device. It's HSL Logistic, and we compared our own legacy GPS that we used and the real GPS. So when we detect these faults in our own GPS, we get a lot of different locations. So we cannot know which one is true. So we always create a circle. We used to create a circle for them to say, just check out this location. But this precise positioning, we normally get very, very exact. Bad acceleration signal is always mapped to the same location. So it was very surprising. It was very nice actually to see that.
And we want to move on to our next startup, which is Smartmoov. They're based in France, and they're working on something else than what we've seen so far. They're working on a device. Exactly the device will be about, we will show you in a second in their video.
Remember when you were doing your driving lesson back in the days? The pedals, the steering wheel, the traffic? A lot of information that are only accessible throughout our memory. What if there was a tool designed to help you get better, faster? That's what Smartmoov is all about. Smartmoov is a French startup created by Stéphane Pau in 2016, with the will of revolutionizing practical driver training. Smartmoov is developing an educational software that records the driver's trip and detects various driving incidents, such as quick acceleration, speeding, etc. At the end of the trip, a statistical report makes the driver aware of areas where there is a room for improvement, helping him to become a better driver. Our product is used by driving schools as an educational tool, but also by professional training courses, road safety associations, and insurance companies. To automatically detect incidents and report back the trip to the students, we need very precise positioning data. We took the concept of the dashcam and we pushed it to a whole new level. Now we detect driving incidents automatically and merge them into a replay video. It's available with a statistical report. Now, let's give you some insight on how our product is used in real conditions. The instructor picks up his phone and opens the remote application we made to control the dashcam. On this application, he connects his phone to our device and lands on a page where all his students are listed. Our instructor then picks the student who is driving and starts the trip. In the background, the dashcam will record the road and save the precise GPS location the Swift navigation module grants us. As the trip goes on, the student is likely to make driving mistakes. If the instructor notices it, he can declare a manual incident straight from the app. At the end of the lesson, the instructor can show the video to his student to go through the points he thinks are important. Once the data is retrieved, the student will be able to see the trip he's made and the statistics. Thanks to the Swift navigation solution, we can provide an accurate and reliable summary to the student. Today, the link between Swift navigation and Smartmoov is revolutionizing driver learning for a safer road.
Thank you, Smartmoov, for your presentation. We don't want to lose any time. Let's move on to the Q&A together with the jury.
Could this also be used for insurance? I'm thinking maybe pay as you pay how you drive kind of thing. If you're a bad driver, or even the rental market, when you're renting a car, Could it be used in these scenarios? Okay.
So as I said in the video, we sell mainly to driving school because it's our goal to sell to it. But in the future, yes, we want to work with insurance companies, and we already signed a POC with Allianz. So we already work with them, but it's the beginning of the working. Yeah.
Okay. Good to know. Thanks.
And what are some of the capabilities you're able to achieve using the precise positioning that you wouldn't be able to do with the standard GPS from the phone?
So in city we had a lot of problems with the precision because we detect automatic incidents with the position, and with normal GPS the accuracy in city is not very good. So we must see the lane detection to have something great for automatic detection for incident.
Two more startups left, and I would like to welcome the next startup actually. They are SolarCleano. So, sorry for that. They are working, or they are based in Luxembourg, and they are working in the robotics field as well. Especially, they are working in a robot that is cleaning solar panels.
Hi, this is Babak here. Thanks for the pitch, Christoph. Very impressive. Just wanted to check, so you have two robots in that video. Would it be correct to assume that precise positioning is relevant for both of them?
Definitely. So one robot is the transporter and the other one is the cleaner. We have several cleaners for one transporter. The transporter enables us to bring the robot from one solar panel row to the next one. and back to the docking station. So basically we need precise positioning for both robots, because the cleaner can cross some gaps, which enables us for the transporter to be a little bit away from the panels and avoid any conflict against the panels. But accuracy is really important, because the panels have a slope, and obviously in our use case you understand that if we are not precise enough, the robot may fall off the panel, which is something that we really want to avoid. And we need to clean also the beneath part of the panels, which means that we need to drive very near to the edge, and this is only feasible thanks to precise positioning.
Thank you. Another question, if I may.
Go on, Babak, because I've got a funny one. Go first, and then I'll go after you.
Just wanted to know, sort of, is the idea that you have sort of one robot that moves from solar park to solar park, or do they need to be cleaned so often that you basically station a robot in a large park and just goes from panel to panel?
Well, it depends a little bit on the size of the parks. Obviously, the bigger the parks are, the more the probability that the robot stays there, or the higher is the probability that the robot stays there. However, in Europe, we do not clean on a daily basis, but more on a biannual basis. So the robots are meant to move from parks to park in the European market. In other regions where you have sandstorms and other situations, the robot needs to be very reactive, and then the need to have local solutions is higher. And in those regions, usually the parks are remote, so difficult to access, which is why the robots needs to be locally positioned.
Thank you.
Let me just quickly ask, what do you use to clean with it? Is it detergents or just water? The reason I'm asking is because I read in Germany, for example, people grow stuff underneath the panels and it helps because of the heat and the humidity. So, yeah, what do you actually use to clean the panels with?
There are two types of cleaning, wet cleaning and dry cleaning. Wet cleaning is used mostly in northern part of the world, so European region, North America, because, as I said, you need to clean twice a year, and in that case you only use water, eventually osmosed water, so purified water.
Okay.
But you can grow plants beneath.
Cool.
And for dry cleaning you use nothing.
Okay, thank you.
Our next startup coming, Zeus Scooters, they're based in Ireland, and they are working in precise positioning and shared mobility. So basically they're working on a 3-wheel scooter. How exactly that will look like, we will see in a second.
Hello, I'm Alexander McHale with Zeus Scooters. As a premier micromobility operator, Zeus is always seeking innovative ways to first and foremost increase rider safety, to deploy valuable features that differentiate us from the competition, and to significantly reduce operational liability and costs. With SwiftNav's precise positioning solutions, we have identified several ways of achieving the goal we have set out for ourselves by leveraging centimeter-level GPS accuracy. One such example is drunk rider detection. Using 10 Hz precision positional information coupled with inertial sensor data, each vehicle's edge device in nearly real time can process and identify impaired riding behavior and intervene by slowing or stopping the vehicle completely autonomously. Such detection technology is cheaper and more consistent than competitor implementations such as onboard cameras and AI, and less defeatable than app puzzles or codes that can be completed by another rider, and worse yet, a rider can become more impaired after that ride has already been initiated. Other dangerous riding behaviors such as riding in traffic or riding on the sidewalk can be detected in the cloud by using advanced algorithms or artificial intelligence. As centimeter-level positions are uploaded to the cloud every several meters of travel, AI is applied to these positions to determine if the vehicle is left or right of the bike lane. Based on the local municipality's road and riding laws, decisions can be made autonomously and enforced on the vehicle in nearly real time, whether that means speed restricting the ride temporarily or automatically bringing the vehicle to a stop, ending the ride, and locking the vehicle in a safe place. Another great example is turn-by-turn navigation. The last thing any operator wants is for a motorist to handle their phone during a ride and operate the vehicle using only one hand. Similarly, providing a place for the rider to dock their phone comes with its own risk, in that a phone can fall from the vehicle when going over bumps, or more likely so if the vehicle is dropped or falls over. By simply offering a means and app to enter a destination and enable turn-by-turn nav, waypoints can be calculated prior to ride start and downloaded to the vehicle. As the vehicle approaches these waypoints, audible, visual, and haptic feedback can be delivered to the rider to ensure the correct turns are made. Lastly, with precise positioning, parking violations can be a thing of the past. Upon ending the ride, the final location of the vehicle is sent to and processed in the cloud. Again, using AI, positional information is virtually overlaid on satellite map tiles, and precise distances from fixed objects are calculated and validated. In doing so, we can determine if a vehicle is parked too close to a building, blocking a sidewalk, or generally illegally parked based on the local ordinances and predefined no park zones. Precise positions prevent false positives, keep customers compliant, and reduce the possibility of fines and tickets raised by the local governing bodies. These are just a few examples of the possibilities that precise positioning offers, only possible with SwiftNav's premier offering. I sincerely thank you for taking the time to watch this video. Be on the lookout for Zeus Scooters in your city. We will see you soon.
Thank you so much, Zeus Scooters, for your presentation. We want to move on to our last Q&A of the day.
Drunk driving in Ireland with scooters? I don't believe it. Come on now. But no, I like the way your use cases kind of address a number of issues that are with e-scooters. Whereabouts are you, by the way? Where can you give me a few cities where you are already?
We're in Germany, Sweden. I know there's quite a few cities in Germany, but Sweden, Norway, I believe Oslo's one at the moment. We're entering Italy just now. That would be this week.
Okay.
We're piloting in a couple other cities, but I had the list is on the website. I don't know.
Okay, cool. Thanks.
The requirements that you mentioned, Alex, this is Babak here. Do they come from the cities? Do they come from your customers? Do they come from official regulators? So where does the business need to make these improvements come from?
Yeah, predominantly it does come from the municipalities. They tell us where, of course, riders cannot ride. They often tell us what the requirement is for distances from a building where they cannot be parked. And for the most part, it's just, I would say, general common sense and trying to protect riders that shouldn't be on these devices. And it's the same problem that most competitors have. So we're just trying to be different and provide a better service.
Can you talk a little bit about what you were able to demonstrate or test as part of the program?
Yeah, sure. So with some of the receivers that we've tested so far, we can get between 25 centimeter and 50 centimeter accuracy. And of course, like I said in the video, what that gives us is the ability to determine if it's an actual position left or right of where we want them to be riding, or as opposed to the accuracy without such a system, we're getting lots of drift and just random coordinates, and we can't really trust that. So at this point, it's more so that we know where the scooter actually is instead of where we would expect it to be or where we'd hope it to be.
That was actually the last pitch of the day. Thank you so much to all the startups for taking the time, for preparing your presentations and taking part in this program. As you know, we have a special jury prize for the best use case of precise positioning. So I hope you can understand that we will need some time now, need to discuss and see who the winner will be. So thanks again to each and every one of you. I'm pretty sure it will be a tough decision. We will see you in a second again. Thank you so much for your patience. It has been a really, really tough decision. We've seen many, many great use cases, and we really appreciate everyone who is taking part in this and taking the effort over the last month to show everyone how precise positioning can help your product and your use case. Nonetheless, we had to choose a winner and we've made a decision. And for that, I would actually like to hand over to Babak now, who's the technical product manager at Deutsche Telekom. And of course, he has also highly been involved in this program and in the organization here. So Babak, moving on to you, handing over to you.
So first of all, again, also let me thank everyone that participated in the program, the startups, the mentors, but of course also the team that organized it. It's been super fun, and I was very impressed by all the pitches that we've seen today. Every single one represented what we wanted to see in terms of creativity, in terms of market understanding, in terms of technology understanding. So in the end of all, it came down to a really close, almost a tie here. So we had three favorites that were really almost peer, which were not PANTOhealth and Angsa Robotics. And I'm very, very happy to announce that the prize money and the jury prize for this year's Accuracy Unlocked program goes to Angsa Robotics. Congratulations. We love the way you presented what precise positioning can do for the solution. We love the way that it has sustainability in there, which is a big thing for Deutsche Telekom. And we really hope that the prize money can give you some some room or give you some boost with developing this solution, and we hope to see it in German parks everywhere soon.
I guess it's my turn to say something now.
Please.
Thank you very, very much. Like, we are all in the room together here in the office, although it's just me at the camera. The others are following the YouTube stream. And we are all super happy. The whole team is happy about that, about the work, and it's just really an honor to be the winners of this prize. Although we have seen so many really, really cool solutions in the whole stream. So thank you very much.
A big thank you to each and every one of you. The program is kind of officially over, but it won't be. You are all still allowed to keep on using the device and to keep on improving and seeing what it can do to your product. So we're really, really excited to see how your journey will go on after this program as well. And we're really happy that you've all been part of this really, really cool program.
And my special thanks to the whole Hubraum team who organized this great event for us today and who orchestrated the whole program in the last month. This was a great work.
So thanks so much again. We probably see you soon again. Big thank you to the jury. Big thank you to the mentors who've always been there for the startups to support. So thanks again. Have a really great day and goodbye.